Hello, my name is Steve. Welcome back to my YouTube channel. In this video, I'll do the Chapter 10 review, Factors in Two Dimensions, from Mathematics Extension 1. Here are the summaries of this chapter. Here's several knowledge points. The first one is the addition of factors. When factor A and factor B are head to tail, then factor A plus B will be from A to B. Here is the A plus B. If factor A and B are tail to tail, then A plus B would be the diagonal of the parallelogram formed by AB. So here will be the A plus B. Okay, next one. Subtraction of factors. When factor A and B are tail to tail, then here this factor will be A minus B. The direction of A minus B is from B to A, going this way. Okay, so this one would be A minus B. Okay, next one. We have two forms to present the factors. One is Cartesian form. The other one is component form. For example, the factor A, if factor A equal to 3, 2, then in the component form, factor A equal to 3i plus 2j. So there are no difference, okay? Just a different form. When we say two factors are parallel, then we have the factor A equal to a proportion of factor B. A equal to a k times factor B. Then we can say factor A is parallel to factor B. When the dot product of A and B is just equal to the magnitude of A times the magnitude of B, okay? When we say two factors are perpendicular to each other, then the dot product of A and B equal to 0. Because when two factors are perpendicular, the cos theta equal to, this one is cos 90 degrees. So here is 0. Then we have a 0 over here. Then we can say the factor A is perpendicular to factor B. Okay? In scalar projection, the formula for scalar projection, A onto B, is A times the unit of factor B. Or we can have A, the dot product of A and B, divided by the magnitude of B. Here's the scalar product, scalar projection. And also we have factor projection. The formula for factor projection is when here this one is A, this one is B. Here's the B. The formula for factor projection of A onto B, so A onto B. So here the factor projection, the red factor is over here. The formula is A, the dot product of A with the unit factor of B, and then times the unit factor B. Or A dot with B divided by B dot with B, and then times B. Okay, so here's the two formulas. Also for factor projection of A perpendicular to B. So here is A. Here is the factor projection on A on B. This factor going up is factor projection of A perpendicular to B. The direction is going up, okay? Going up, going to the B, going to the A, pointing to the A. The formula is A minus the dot product with A, the dot product of A with the unit factor B, and then times the unit factor B. Or A minus the A dot B divided by B dot B, and then times B. Here is the same to this one. Here is the same to this one. So using A minus the factor projection, so A minus the factor projection equals to this one, factor projection of A perpendicular to B for this one. Okay, let's have a look at some questions to practice. Okay, let's have a look at some questions. The first one, given the position factor OA equal to negative 3i plus 4j and OB equal to 4i plus 3j, what's the value of the magnitude of factor AB? So the first step, we have to find the factor AB and then get the magnitude of the factor of AB. Okay. Okay, first one. So AB factor equal to, we can get the AB from OB minus OA. Okay,
So OB minus OA. So equal to, for the I is 4 minus -3. So you've got 7i. Plus 3 minus 4 is -1. So it would be 7i minus 1j. Okay, so the magnitude of AB equal to the square root of 7 squared plus 1 squared equal to square root of 50. So square root of 50, you can take 25 out of the square root. So you've got 5 square root of 2. Okay, so the answer would be B. Okay, the next one. ABCD is a trapezium where vector DC is parallel to and twice the length of the vector AB. Let vector AB equal to vector A and vector BC equal to vector B. Therefore, vector DA is equal to... Okay, let's do the graph of the ABC trapezium. So DC is parallel and twice to the length of AB. So here's AB. Okay, so here's the trapezium of ABCD. And vector AB equal to vector A and BC. BC is going to this direction, equal to B. Making sure we are having the correct direction of each vectors. Okay, so here's the BC. Therefore, the question asks for DA. The question asks for this one, DA. Okay, so far we have vector A and vector B over here. And because vector A and vector B is head to tail, then if we want to have the A plus B is going to this direction. Right, so this one's A plus B. This one. And in CDA, the vector DC and vector DA is tail to tail from here, right? Then we have DC minus DA equal to AC. Okay, in this triangle, CDA. CD or DC. DC minus DA equal to AC. Okay, then we have DC minus DA equal to AC. DC equal to, so here's A, then here's 2A. Because the length is twice to AB and parallel to AB. So here's 2A. So here is 2A minus DA. So we are looking for DA equal to AC. AC equal to A plus B. Then DA equal to 2A minus A plus B. So DA equal to 2A minus A plus B will be equal to vector A minus vector B. Okay, so here is the vector form for DA. So the answer would be D. Alright, next one. Question 3. Given vector A equal to -2i minus 5j and vector B equal to 3i minus j, calculate the magnitude of 3b minus 2a. So same thing to the question 1, we have to find the vector of 3b minus 2a first and then get the magnitude. Okay, so the first one would be 3b minus 2a equal to 3b would be the b times 3 would be 9i minus 3j minus 2a. So minus 4i minus 10j equal to 9 minus -4, we got 13i. -3 minus -10 is plus 10, will be plus 7j Okay, so the magnitude of 3b minus 2a equal to the square root of 13 squared plus 7 squared equal to 169 plus 49. So 16949 plus will be 8218 equal to the square root of 218. Okay. Let's try to simplify square root of 28, because 28 divided by 2 will be 109. We can't get any factors for 109. So we just keep square root of 218 as your final answer. Okay? So here's your final answer. Let's have a look at question 4. In question 4, consider two factors, factor A equal to 2i minus 5j, and factor B equal to negative 3i minus j. So the first question is find the scalar projection of A in the direction of B. So here is scalar projection. Making sure we are using the correct formulas for scalar projection, okay? So scalar projection of A onto B is A dot product with B divided by the magnitude of B. Okay, so the dot product of A and B would be 2 times negative 3 is negative 6, and negative 5 times negative 1 is positive 1 divided by the magnitude of B would be square root of negative 3 square plus negative 1 square. Okay, will be negative 1 divided by square root of 10 equal to negative square root of 10 divided by 10. Okay, so here is the scalar projection of A on B. The next one is factor projection. So we are looking for factor projection of A onto B. So different formulas to the first one. Okay, for the factor projection would be A dot B divided by B dot B and then times B. Okay, so here's the formula. Okay, A dot B will be this one, negative 1, divided by D dot B would be 9 plus 1 would be 10. And then times factor B, negative 3i minus j equal to, so we bring this negative into the factors. So we have 1 over 10 times 3i plus j. Okay, so here is the factor projection of A on B. In C, find the factor projection of A perpendicular to the direction of B. So the formula for factor A perpendicular to factor B would be A minus the factor projection. Okay, so A minus this part. So factor A dot product with factor B, and then over D dot B, and then times B. Okay, so we can get the value of this one for this one. So it would be A is 2i minus 5j minus 1 over 10, 3i plus j. Okay, so for the I would be 3 minus 2 minus 3 on 10. So we still have 17 over 10 I minus, so here's a minus 5 and then minus 1 on 10. So it would be minus 51 on 10 j. Then here, because 51 is 3 times 17, right? So we can factor out the 17 on 10 of the factor equal to 17 on 10, and then I minus 3j. Okay, next one. D, hence and express the factor A 2i minus 5j in terms of the projection parallel to and perpendicular to B. So in the graph, okay, then here. if this one's A, here is the vector projection. So if this one is A, here is the A vector projection of A on B. And this one is the vector projection of A perpendicular to B. So this one is perpendicular. Okay?
So the question asks for A in terms of the vector projection and the perpendicular projection. Okay?
If this vector and this vector, so A would be this vector projection plus the perpendicular projection, right? So we have A equal to the vector projection plus the perpendicular projection would be 1 over 10 3i plus j, and then plus 17 10i minus 3j.
Okay, that's it. Okay, let's have a look at the last question in this chapter. Question 5. In triangle ABC is a right angle triangle, and M being the midpoint of the hypotenuse of AC. So M is the midpoint of AC. Let AM equal to vector A. Making sure we are having the correct direction of the vectors, okay? So vector AB is vector from A to AM. Vector AM is from A to M. From A to M. So here is the direction of AM. So this one would be A, vector A. So BM, so from B to M. This one would be vector B. Okay? So the first question is find the vector AB and vector BC in terms of A and B. Okay?
So vector AB equal to, vector AB is this direction. Since AB and AM is tail to tail, right? So this BM equal to the AM minus the AB. So we have BM equal to AM minus the AB. Then AB equal to, so the AB equal to AM minus the BM equal to AM is vector A minus the BM's vector B.
Okay, so we have done for the vector AB. Alright, let's have a look at BC.
So BC is from B to C, this direction. Okay. In the triangle BMC, another vector for MC and MC over here. MC also is A. Okay, since AM and MC have the same magnitude and same direction, so we have AM equal to MC equal to the vector A. Okay, and also we have AC equal to 2A.
Okay, so here's the relationship between AM, MC, and AC.
Okay, in BMC, so here's the MC is going to this direction. BM is going to this direction. So BC, so here's the BC, just the sum of this vector BM plus MC. So here's the vector B, here is the vector A. So vector BC, just vector B plus vector A. Okay, so we have BC equal to vector B plus vector A, or vector A plus vector B. Okay, they're the same. Okay, so we got the answer for vector BC, and also we get the answer for vector AB.
In question B, prove the M is equidistant from the three factors of the triangle ABC. So the question asks for these points M have the same distance to A, B, C. So for the first step, we have known M have the same distance to A to C already, because M is the midpoint of AC. And then we have to prove the magnitude of A equal to the magnitude of B. Then we can say the M have the same distance to A to B as well. Then M have the same distance to A, B, C. Okay, so we try to prove the magnitude of A equal to the magnitude of B. Okay, we can starting from, because AB is perpendicular to BC, because here is a right angle. Then we have a AB dot with BC should equal to 0, right? Okay, AB is equal to this one, BC equal to this one. Then we have AB vector dot product with BC equal to A minus B times B plus A equal to, we can change this one into A plus B, okay? It just make us easier to do the calculation. So this one would be just A square minus B square. The magnitude of A square minus the magnitude of B square, okay? So the magnitude of A square minus the magnitude of B square. Since AB is perpendicular to BC, such that we have AB dot product of BC equal to the magnitude of A square minus the magnitude of B square has to be equal to 0, right? Which means the magnitude of A has to be equal to the magnitude of B. Then M have the same distance to A to B, which means M have the same distance to A, B, C. Okay? Then we can conclude that hence M is equidistant from the three vertices of the triangle ABC. Okay? Yep, that's the last question for this chapter. That'll be all for the chapter 10, Factors in Two Dimensions review. In the next video, I'll do the reviews for chapter 11, Applications of Calculus. Hopefully my videos could help you to have a much better preparation for your HSC exam. If you like my videos, please give me a like, and subscribe my YouTube channel. I'll see you in the next video. Bye bye.